Hello everyone, welcome to today's session. My name is Wycliffe, and in this video I want to share with you how you can monitor the health of a forest using a normalized difference vegetation index in RGEE or using the package RGEE. Now, NDVI measures the health and vigor of green vegetation by quantifying the difference between how plants reflect red light and how they reflect near infrared light. If a plant is very healthy or healthy vegetation absorbs more red light for photosynthesis and reflects more near infrared light. So a higher NDVI value indicates more abundant and healthy vegetation, while low NDVI would indicate unhealthy vegetation. So let's get into R. So we will start by loading the necessary libraries, and our first library will be RGEE. Okay, let me increase the font a bit, or the zoom in a bit. Okay, so after loading the RGEE, we'll load SF or map edit. We'll start by map edit. Map edit will enable us to draw our region of interest around the forest of interest. Okay, then we'll load dplyr to help us wrangle the data, bit of the data. We will not do a lot of wrangling, but just a little bit. And then we will need tidyr to clean some names to make our data or even pivot it. And then we'll also need ggplot for visualization. We'll draw a plot of trend of vegetation health over time. And then we will also need SF package, SF to handle simple features. Okay, so as usual, we start by initializing our Google Earth Engine session, and then we can draw our region of interest. And for the region of interest, we'll use draw features, we'll use draw features, which is a function from map edit. Once we've drawn the features, we'll create a name. Now we are using mutate from dplyr to create a name or to add a name column to our features or simple features. So we'll call this Arabuko. Okay. After that, we'll only select that name. So we just say select name. Okay. So we get an interface here. I will go to the coastal region of Kenya towards the lake, the ocean, and then draw a region of interest. So I will select this forest, which is called Arabuko, and pick this drawing tool. Then not very accurate, but for your case, you need to be very accurate when selecting your region of interest. Yeah. Interactively draw a polygon around the forest, and then like that until we get to the first point where we started. Okay, then we click done. So we have our simple features. We have our simple features as region of interest. So if we check region of interest, we realize that it is a simple features with the name Arabuko and the geometry of the polygon. All right. So after that, we can convert this region of interest into an Earth Engine object, right? So we use SF as EE function to convert the region of interest to Earth Engine object. So if you check region of interest, it's now a feature collection which we can use to do filtering by bounds, filtering bounds, and also clipping and extraction of values from Google Earth Engine, right? So let us visualize our region of interest. So we'll say, first of all, we will center our map to the region of interest. So the Earth Engine object is region of interest, and the zoom level we can set to maybe 11, like that. All right, let me expand this a bit. So that will set our mapping area around region of interest, which we've digitized, and zoom it to the level of 11. Then we can add layer. We can use map add layer function, and then our Earth Engine object is the region of interest, and visualization parameter, or we can just style this region of interest instead of adding visualization parameter. So in the styling, we set color to be any color of our interest. For example, we can go with yellow, and then for the fill color, we set a transparent color so that we don't see, we don't fill in, so that we can see um, the forest in the background, right? Like that. So that will draw our region of interest around, which we will show us the region of interest, and we can still see clearly the forest in the background, like it is not gray filled. All right. So after that, we'll pick our start date. For example, let's say we want to monitor our forest between the year 2000 and 2025. So our start date will be the year 2000, 1st January. Okay. And then our end date will be 2025, the first day of January. So this will not be included. So the last day will be December 31st, 2024. All right. So let us get a data set which covers this period. For example, Landsat dataset or Landsat 7 dataset covers started operating in 2019. So it covers this region until 2024. So we can use Landsat 7. We cannot use Sentinel here because Sentinel only started around 2014, 2013. But we want a long-term monitoring of our forest. So we'll use Earth Engine $, and then image collection, because Landsat collection is an image collection, and then we go for Landsat, dataset, and then Landsat LE07, LE07, and then C02 T1L2, this one here. All right, so we have our Landsat image, so we can do the filtering. So L7 will be the L7, and then we pass it to, we filter it by bound. So we filter all the images from 2000 to date, or to 2024, using our region of interest. That is filter bounds. After that, we filter date. So we filter for the period of our interest, which is the year, which is start date. We already defined them. So we can say start date to end date, right? So that gives us the image collection we are interested in, or the period which we are interested in. Okay. So after getting all the Landsat images from the year 2000 to the year 2024, we can then map a function on our image, right? So we want to clean this image, for example, because the image has got some clouds. And here we cannot use CS+, which I've used in my previous videos, because now we are working with Landsat, okay? So the quality assessment band from Landsat, we will select from the image. So the image which we are picked, for example, the first image, and then we pick quality assessment pixel. It is denoted by QA pixel. And then here we use bitwise and to clean to pick the bits that are cloudy, and then remove them or equate them to 0, right? To pick those that are equal to 0. And then the saturated band is also another band which helps us to remove saturation, or do away with saturated pixels. So we will have to mask our image using this QA saturation band, right? So it's called RADSAT, QA RADSAT, and then we also look for equal to 0. Okay, so if you check for Landsat 7, you will find these quality assessment bands in the as some of the bands in each image. So we can use them to clean our image. Okay, then we will pick only the optical bands. So we can say optical bands are from the image. We will select all bands that start with SR_B dot, right? So all bands which start with SRB, those are optical bands. So what do we do with them? We scale them, right? So we multiply them by 0.40, then 275, right? And then we add negative 0.2. Negative 0.2. If you are wondering where all these are coming from, if you look at Landsat 7, Landsat 7, LE07, T2, Tier 1, Level 2, this one, and you look at the bands, you will see the SRB bands. So we have quality assessment bands, the QA, way down here, the QA pixel bands, and we also have QA RADSAT band, radiometric saturation band, which can help us in cleaning the image. All right. So, and these scaling factors are the scaling factors for the optical bands, right? Okay. And then from this, we get our image, sorry. After adding this, we can then clean our image. We didn't have to set this. This one need to go inside the function call itself, by the way. So we need it up here, the optical bands. And then after picking the optical bands, then we get the image up here will be the image itself, but now we add bands, right? We add bands to this image, and the bands we are adding are the optical bands. Those are the only bands we are interested in, optical bands. And then we set other attributes like geometries to null or other information, and we return true. Okay. After that, after adding the optical bands, we can then update mask, because we've created the two masks for the quality and the saturation. And then we use the QA, and again, we update mask with the SAT, or the saturation. Yeah. Okay, after that, we can calculate our NDVI, because we want to monitor the health of the vegetation using NDVI. So for each image, we'll use normalized difference. And for the normalized difference, we only need two bands. We need SRB, SR band 4, and SR band 3, in that order. SR underscore band 3. So this is the red band, and SR band 4 is the near infrared band. The order is very important. So you don't start with red, then near infrared. You will get the opposite of NDVI. So then we rename it to NDVI, and because we need to do a time series, it's important that we return the NDVI with properties. So copy properties. And the properties we are copying are from image, whereby we pass it as a list, which is a list of system time start. So we set system time start. So each of our NDVI will get its original bitwise and typo. There is a typo in the bitwise. Bitwise and yeah. Copy properties. Copy properties. Properties. Okay, like that. That should work now. Okay, so once we have our NDVI, this is now a lot of NDVI images all the way from the year 2000. So we need to calculate the annual NDVI. So to do that, we need a years list on which we do the mapping. So we pick Earth Engine and then we create a sequence of list or a sequence of numbers which contain the years from the year 2000 all the way to the year 2024. All right. Once we have the years, then we can calculate our annual NDVI. And our annual NDVI will be on the years we do map, okay? We do map a function, right? So the function we are going to map, sorry, just bring this up. We map a function which takes year, not image, because we are mapping over years, which takes year. And then that year, we are going to apply a Python function, utils function to help us in this, okay? Utils py function, this one. And then in that, we provide a function which takes year. So for the years, we map that function, right? So we don't need this. We map the pyutils function. And it's inside this function that we provide, these arguments. So here we will have the year defined as EE $number, and then it takes the year. So for each of these years, okay? After taking the year, and making it an Earth Engine number, we can set our start date. So our start date will be EE Earth Engine date, and then from year, month, day, and then we pass the year and the first day, all right? And then the end day for the year would be the start day, and then we advance it by 1 year, like that, okay? After that, we will get annual image. We can now get our annual image. So our annual image, or IMG, we can get it by picking our Landsat 7 list of images, right? And then we filter date. So we filter date starting from start and ending from ending at end. So the first day of the year until the last day of the year, we do the filtering for that. And then after that, we can get maybe mean for the year, mean NDVI for the year, right? Okay, after getting the mean NDVI, we can rename our NDVI using a string, because when we get mean, the start date and all that information is lost. So we need to set a new name for it. So we can say our NDVI will be the NDVI with the year. So we also add the specific year it came from. And this year, we need to format it so that it doesn't have trailing zeros. So we make everything digits or integer, if you wish. Okay, so after that, what do we return? We return an image or annual image, which we have created up here. I will just copy it direct. We return that image, but we set year on it so that we know which one is for which year. Okay, so just like that. There is an error, year not found. So let me check where that is bringing the problem. Year, and then year. Okay, so did I run this? Okay, I ran that, but it's still bringing problem. So we get our annual NDVI, which is on years. We map utils function, which takes a function year. Okay, so that's where we missed the year. Okay, so now we have our annual images. So, but it is a list of images because we are mapping over a list of years. So we need to convert it to an image collection. So annual NDVI, we can make it even annual bands now. We can call it annual bands. Will be at engine and then image collection and then image collection and then from. Where are we getting those ones? We are getting them from images. And which are these images? The annual NDVI, which we created here. Okay. Right. So after that, we have our image collection, which we can then convert to bands, just like that. Okay. So these are annual bands, an image with several bands representing the number of years, right? So it's an image at engine image object. Okay. So, but this image has got, because we use this to bands function, the names have got some trailing or prefixes which are numbers. So, for example, if we print the band names for this, so annual bands, $ band names, and then get information like that, we'll see some trailing zeros, right? So these zeros, we need to clean them a bit so that we don't have them in our images. So we can say the old names are from annual bands, $ band names, right? Those are the old names. But now we need to clean names, or yeah, we get clean names, which are old names, right? But we map a function over them. So map e by utils or utils by at engine utils by function. And then this function, we provide a function in it, which takes a name, one of the names. And then after taking a name, what it does is that it passes it to string and then that name, and then we replace it. So we can just use replace function there with nothing or everything. You can say if you see that, yeah, if you see anything between 0 to 9, then and followed by underscore, right? So 0 to 9 followed by underscore, if you remember those names, 0 to 1, any digit numbers that are then followed by underscore, replace them with nothing. That is, remove them, right? So that function will give us clean names on the from the old names. Then we can now have annual bands which are clean by renaming the original annual bands. So the annual bands we had here, we just put $ and then we rename it with the clean names. Clean names, right? So if we check the band names of this, they will now not have the trailing zeros. $ band names and then get info like that. So we have deleted, we have removed all these digits that were appearing before the word NDVI. Okay. So after that, we can then extract NDVI values for our forest for all those years. So we'll call them stats and we'll say from this annual bands clean, reduce region, because we just have one region. Reduce region in which the recollection, or we can say reduce regions, just to get a feature collection which is easier to work with. Our collection is the feature collection which we created here, which we call the region of interest. And then the next thing is a reducer. We can say reduce with the median. So we can have a reducer which is median NDVI. And then we need a scale, right? We need a scale. So we can extract it at a scale of 30. Okay. So that does the extraction of NDVI for each year, because here we have several bands per year, or every year as a band from 2000. So that's around 25 images. And for each of those, we get the mean NDVI, and they're clean images, right? So to convert, this stats here is a feature collection. You see, it's an Earth Engine feature collection. So to convert it to SF, this is very, very simple in RGEE. So we just say Earth Engine as SF, and then we pass the stats. This might take some time because we have this is a large forest, a relatively large forest, and it has got, and we are extracting at a resolution of 30 meters. So every 30 by 30 meters, it handles the pixel and then gets the median, extracts the pixel value, and then reduces it to its median, picks the middle kind of NDVI across all the NDVIs present in that year, in particular year. And it does that 24 times or 25 times, right? So let's give it some time. If it takes too much time, we can change this scale to maybe 100. So we'll be talking about 100 by 100, 100 by 100 pixels at the same time, right? So that can speed up the extraction. So it should almost be done. Okay, while it's working, we know we will convert it to a data frame. So we can say stats df will be the stats SF, and then we drop geometry. So this is why we needed the SF function. It has that ability. And then we will then make a data frame with it. We will then clean it. It will come as a wide format data frame. So that is, each year is a column. So we need to pivot it long so that we have a long format, which is easier to work with. So we'll say stats df gets stats df, and then we pivot longer. We use pivot longer from tidyr, and then the calls, because we created a name for the forest. Okay, the stats df is done. So we can continue with that, dropping the geometry. You can have a look at it. Each year, for example, NDVI 2001. Let me expand it a bit like this. Then rerun. So we have the name, which is Arabuko, then NDVI for 2000, 201, 202, all the way up to 2024. We have the values. So that is the name which we are negating here or removing from the columns, and we are keeping all other columns. And then we set names to, we can say maybe year metric. Let the names go to the year, and then values go to NDVI, right? We can call it so. So if you look at this, it will now be shift like that. It will now be a long format like this. Year metric, NDVI, and then the name. the name is just one. If we had several polygons, they will be more, okay? So NDVI for 2000 until 2024. So then we pass that. We don't like this kind of year where year is also is a character, like it has NDVI and then year. So we need to separate this the year from the word NDVI because we only need the year as an integer. So we use separate function from dplyr, and then we use the year metric. The year metric, which contains NDVI and the year, and then we separate it into two things. One, we separate it into prefix, that is the NDVI with underscore, and then we also separate it into year. That is, one part of it goes to year, one part of it goes to a column called prefix. And how do we separate it? We separate it at NDVI underscore, right? If you look at the name, so NDVI underscore. Okay, so the separation is at NDVI underscore, right? And then, so you can have a look at this alone up to here and run that and see how it looks like. So we have this one, and this is separated character. For year, we have the year value, and then we have the NDVI. Okay, prefix is returning nothing. Separate NDVI and underscore values to NDVI. It was just NDVI without underscore. Yeah. Let me look at this. No, it should have NDVI. No, it's passing underscore. Separator. What if we tag this? I'm wondering why this is not. It should be. That's df. Okay, it could be because we did some cleaning up here. Okay, then let me check again because I don't understand why it's not returning the NDVI. Anyway, what is of interest to us is the year and the NDVI. I will find out why it is not separating this the way I want it, okay? After that, we make our year as integer because you can see it's a character as integer of the year. And then once it's an integer, we can just select what we want. So we select the name of the place, we select the year, and we select the NDVI. Yeah, those are the three things of interest, and we can arrange in order so that in case the year was mixed up, then we can see our object clearly. Okay, so we run that. No. Yeah. So if we look at stats.df, it should be having the name, the year, and the NDVI value, respective NDVI value. Okay, so let's get to almost the final bit, which is just visualization. So we can visualize this. We can plot this, ggplot, and then we provide the stats df. Okay, and then for the aesthetics, we say on the x-axis, that is calling for looking at the head of this so that we know what we are talking about. Stats df. Okay, so we are talking about year on the x-axis, the numbers, and then on the y-axis, we have our NDVI values, and then we can do grouping by the name just to have a color for it. And then we can also color by that name. Color by name. Okay. And then we can make a geom line. And then we can also add geom point at the intersections of the X and Y axis. And then we can label, we can provide some labels to this, whereby X axis gets the year, and then Y axis gets the NDVI. This is an index, so we don't have a unit for it. Then we have the title of the map of the plot, being maybe annual NDVI from Landsat 7. Landsat 7 for Arabuko. You can format this the way you want, 2024. Okay. And then we can make it have a dim minimal with a base of base size of maybe 14. Base size of 14. Okay, let's have a look at that. All right, so that's how the health or the vigor of the forest has been changing over time, all the way from 2000 to 2024. General trend, we can see it's been declining in health. I mean, there are a lot of reasons that could be leading to this. Some might just be, one might need to go to the ground to understand what happened in the forest, or what people do in the forest, or what policies were put in place at what specific time, or if we see these spikes, was there heavy rainfall or something like that, which increased the health of the plants, or yeah, so there are a lot to talk about in terms of what explains this observed pattern for this particular forest at the coast. So yeah, but generally what we are seeing is that the health of what we can see, everybody can see, is that, yeah, it's declining over time. Maybe more trees are being cut, or it's becoming more bare or something like that. Of course, it's still quite healthy considering NDVI values of about 0.6 or 0.7 or so. It's quite healthy. Okay. So I think that's all I wanted to share with you today, that you can have that kind of long-term monitoring of the health of your forest all the way from the year 2000 or even before 2000. If we go for Landsat 5 or such, we can get data all the way from 1980s, I believe, and then up to the year 2000. So we can even monitor the forest for a longer period of time. Okay, I will leave this script in the description of this video. Remember to cite all the data sources accordingly and the packages you use in your analysis, like these ones, and share with your friends who might be interested in monitoring the health of forest or cropland or something like that using NDVI, and they're wondering whether they can get this information all the way from the year 2000 or below, and how do they achieve it in RStudio or in R. So thank you so much and happy coding. Bye-bye.